Welcome to another time with the enthusiastic tutor. Hello, everyone. Today, I'll be walking us through the rudiment of mathematics, and the topic for today is sequence. Just before we go into details, I'd like to apologize for not uploading tutorials for some time now. I've been very occupied with exams. As you all know, I am currently writing an exam, so I apologize. And not until I finish my exams, upload of tutorials will not be coming up back to back. But for this week, I'll be dropping two tutorials in mathematics. So this is the first one. Look forward to getting the other one as soon as I upload this one. With that being said, let's hop right into it. So today we are looking at the topic. Today we're looking at the topic sequence. And this is our second lesson on sequence. We had a lesson before now on sequence. Now this is just the conclusive part of it. So now, as you can see here, we have lesson 2. Lesson 2. So we have the definition of, we have terms. I beg your pardon, we have terms. So we have difference, we have ratio, we have first term, and we have the end term. This might not be new to you. You have gone through the previous class. This shouldn't be new to you. So we have difference equals to plus and minus, ratio equals to the division and multiplication. And we have our first term is represented by A, and we have earned term is represented by N raised to power TH. You get to understand this as we commence in this tutorial. So our first illustration says 1, 2, 3, 4 to infinity to our N10. Now I said find the first 10 and difference of the above sequence. Now this is a sequence 1, 2, 3, 4, and 5. It's a sequence dash 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 infinity and end stem ends this. So we are instructed to find the difference and the first term. As you can see, to find our first term is A, which is this, as we have denoted here. Our first term equals A, so we have A equals 1. From our sequence here, the first 10, as you can see, we don't have the last 10. This is the first 10 here. Our first term is 1. You can see. So our first term is 1. Very straightforward, right? So we have the difference now. The difference is what we're going to calculate for. Our difference is 1. So how do we arrive at this one? Let's keep watching as we are going to know very soon. Now, said, note the application above is that of difference and not ratio. Now, we are asked to find the difference, and moreover, from the progression of our sequence, we have 1, 2, 3, 4, and 5. So without you being told, this is for difference. It's a different thing when it's a ratio, which we'll get to know very soon. So we have our sequence as 1, 2, 3, 4, and 5. And we can see the signs are here. So we have to find our D. We then say difference equals to D. Now 2 minus 1 equals 1. Now this is our figure 2. Then this figure 2 comes to the front and figure 1 goes back. So we have 2 minus 1. 2 is taken to the front, then 1 is returned back. So we have 2 minus 1 equals 1. That's how we arrive at our difference. So if we had said 3, if we had said 4 minus 3, we have gotten 1 still. And this is it. 5 minus 4, we had 1. So that is simple and straightforward. Illustration 1 is solved. So we're moving to the next illustration. We have 2, 4, 6. It's our sequence. As you can see, the progression is 2, 4, 6, 8, 10, infinity, and the end term. So we have find the first term and the difference of the above sequence. Now, the first term, which is A, the difference is which is D. Now, as you can see, we say A equals 2, which is this, our first term. Then we have D. D, that's the difference is 2. How do we arrive at that? We'll find out soon. Now, excuse me. Note, note, the application above is that of difference and not of ratio. As we said earlier, as you can see, the progression is of difference and not of ratio. Excuse me. So as you can see, the progression is of difference and not of ratio. We'll get to know better in our next illustration. So we have to get our difference, as we did in the previous one. We'll just take 4 forward, then we'll bring 2 backward. Then we apply the minus sign. So 4 minus 2 equals 2. We also have 8 minus 6. We did the same thing we did here. We bring the 8 forward and we take the 6 back. So we have 8 minus 6 gives us 2. And that's how we arrive at our difference. So let's move straight to illustration 3. We have this, as you can see now, this sequence is quite different. We have the progression of this sequence is different. We have 2, 4, 8, 16, then 32. Now, so how do we, it's getting a bit intense now. So how do we do this? We have find the first term and the ratio. Now, as you can see, it's now ratio. It's no longer different because the progression of the sequence is different. Now, this is from 8 to 16. It's from 16 to 8. And as you can see, the difference here is it's like there. It's not a question of difference. Now, it's a question of ratio. Now, we say, note the application above is that of ratio and not of difference. Now, it's still the same process, but it's a different method now. So we have our fourth term is 2, as you can see here, and our ratio equals 2. How do we get our ratio? Now we say we bring 4 here, we bring 4 down, then we bring 8 down, and we have 16, and we have, okay, we stop at 16. So how do we get the ratio? Now we'll do our first term multiply by 2. I beg your pardon. As you can see here, we brought 4 forward. So 4 here, we're going to think of a number. Now, let's pay attention. To get our ratio, we are going to think of a number we can multiply by our terms here, and we'll get the next term. Did you get that well? Did you get that correctly? We are going to think of a number we can use in multiplying our term, and the next figure we are getting is a figure after a term. Now, I didn't use 2 here. Now, let's start with 4. So we have, I thought of the number, and the only number that can do this magic is 2. As we have it here, 2 multiplied by 4, which is our second term, equals 8. 8 is the third term. Now, if you bring 4, 8 and multiply it by 2, it gives us 16, which is our third term. Now, if you bring down 16 and multiply by 2, it gives us 32. And that's how we arrive at our ratio. Let me take that again. To get the ratio of the sequence, we have to think of a figure that can multiply our term and gives us the next term in line. And after the brainstorming, what we arrive at is the figure 2. 2 does it for this progression, for this sequence. 2 does it. So we have 2 multiplied by 4 gives us 8, which is in line, the next in line after 4. So we have 2 multiplied by 8 gives us 16. Then we have 2 multiplied by 16 gives us 32. So that's how we arrive at our ratio, which is 2. Now, another illustration, illustration 4, as you can see, the progression here is different. This is 81, 27, 3, then 9, then 3. So we have find the first term and the ratio of the above sequence. We have our first sequence as 81, and our R as 1 over 3. How do we arrive at 1 over 3? We'll find out soon. Just keep watching and we'll find out, we'll get to know soon. So we have, note, the application is out of ratio and not of difference. But I think it's a typographical error. It's, I think, let's just like ignore that. So we have the sequence here. So to get our R, we then say we bring forth 27, bring it to the front, we bring it forth, then we take backward 28, 81. So we have 27 plus 81 equals 108 divided by 81. Now this takes us back to this illustration. So this is what we have here. As you can see, ratio. Now we're dealing with division and multiplication. Unlike difference, when we're dealing with addition and subtraction. This explains, illustration explains that. I believe we are following. Now we're dealing with this ratio. So we then say 81 is brought behind 27 and 27 is brought after 81. So we have 27 plus 81 equals 108. So we divide it by 81, it gives us our ratio. So we then say 9, which is 9, goes backward. Then 3 comes forth. Then we may say 3 plus 9 gives us 12. Then 12 divided by 9 gives us 1 over 3. And that's how we arrive at our ratio. So we move to the next question. Let's find the first term and the ratio of the above sequence. So we have the first term as 3. So our ratio then is 3. How do we get that? We'll find out soon. So we have the sequence here. So we then say 3. This is applicable to this other illustration where we're multiplying a number that does where we had to brainstorm and think of a number that we can use to multiply our term that gives us the next term in line. So the same thing is also applicable here. How and when do we get to, how do we decipher, how do we dissect when and how to use it? Now, as you can see, this here, as you can observe the progression, we have 3 is like it's in an ascension order, it's going up. We have 3, 9, 27, and 81. Unlike what we have here, we have 3. This is also an ascension order. Okay, no, not this. This here is also an okay. This here is I beg your pardon. This here is descending. When it's descending, what we apply is what we have done here. What we apply is what we have done here. We bring this backward, then we bring this forward, then we do the addition, then we divide. I hope that is understood. Please feel free to ask your question in the comments below. If you find this tutorial very useful, you find this tutorial very helpful, please do well by commenting, giving us a piece of what you think about the tutorial. Making this tutorial takes days, takes hours. Designing, putting everything in place, uploading, it requires a lot of effort and finance. If you find this tutorial very helpful, do well to subscribe to this channel. My contact you'll find my contact in the description of this video. Please do well to reach out to me if you're having any issues with any of your course. Do well to reach out to me. I'm always available. I'm accessible. And please don't forget to use the subscribe button, like and share this video, please. So as we have here, let's go back to our question. As we have here, we have 3, 9, 27, and 81. We then say what number can multiply our term and give us the next in line, which is 3. So about 8. So what we are getting is 3. So we have 3 multiplied by 3 gives us 9. If you bring down 9 and you multiply by 3, it gives you 27. If you bring down 27 and multiply by 3, it gives us 81. And that's how we arrive at our 3. So that is that. That is what it is. Excuse me. So we have question 6. It said, find the first term and the ratio of the above sequence. Now we have the first term is 32 and the ratio is 1 over 2. And we have a 1 over 2. Get to know soon. The application above is that of ratio and not of difference. Okay, so we have 32 plus 16 equals, now as you can see, this is in a descending order, not ascending. So we then use addition and division. So we then say 32 plus 16 equals 48. Then we divide it by 32. It gives us 1 over 5. Same thing is applicable to 8 plus 4. It gives us 12. Then we divide 12 by 8. It gives us 1 over 5. And that's how we arrive at our ratio. I believe we are following. Please, this is mathematics. As you are taking this in, it is expected of you to go back, apply it, look out for other questions, and apply these processes. Take your time and practice this. It's not what you read and cram. It requires practice because it's mathematics. So take your time, follow the tutorial. It requires practice. So take your time, follow the tutorial, and practice in your leisure time. Keep practicing, attempt more questions. If by any means you come across questions you feel a bit cumbersome or they are stressing you, the question is stressing you, you can always reach out to me. I will I won't hesitate in helping. So now this is another question, and this question is a bit different from the ones we've been attempting. So now we have find the fourth term and series of the sequence. So this is the formula for finding term. Now as you can see here, now we're given a specific term to find, and we're also given series, two tasks in this question. So this is the formula we have to apply. We have the un equals n plus 1 all over 2n minus 1. So we have now for T1, we are going to the fourth term. Let's not forget for T1, then we have, according to the formula, we have n plus 1. This is 1 here in the sense that this T represents our U. So we have T1 equals 1 plus, it says here 1. So we apply this here. Then we have our 2n. Then this is the let's not forget that we are looking for the first term. We have our 1 here. Then the formula says 2. We have our 2 there. We have minus 1. We have equals 1 plus 1 equals 2. 2. Then this into bracket this, that's 2 multiplied by 1. This was 2 minus 1, which is 2 over 1 equals 2. So we have our T1, then our T2. So the formula says n. So we have, let's not forget this T2 we are solving for now. So our n equals 2. So we have 2 plus 1. Then we have 2 into bracket n minus 1 according to the formula. So we have 2 and our n is 2 minus 1. So we have 2 multiplied by 2 is 4. So we have 4 minus 1 equals 3. Then we have 3. Then we have 3 over 3 equals 1. So we solve for T3 and it continues that way. So we have 3 plus 1. We have 2 into bracket 3 minus 1 equals 4. We have 2 multiplied by 3 gives us 6. So we have 6 minus 1 gives 5. We have 4, this same 4 we bring forward. The 4 divided by 5, we leave it like that. We leave it that way. So the same thing here, we have 4 plus 1. We have 2 into bracket 4 minus 1. So we have 8 minus 1. Then we have 5. 4 plus 1 gives us 5. So we have 5 over 7. So we leave it that way. So we may then say our fourth term, excuse me. So we may then say our fourth term is 5 over 7. We have, for the first term, we have 2, second, 1, third, we have 4 over 5, then the fourth is 5 over 7. So now calculating for series. Now we have our answer is 2 plus 1 plus these two can also be said to be 2 over 1, then 1 can be said to be 1 over 1. So we have plus 1 over 5 plus 5 over 7. So to solve for series, we need to find the lowest common factor as our LCM. Now to find LCM, to find the lowest common factor, we may say 2 as well as against what we have here, we may then say 2 over 1 plus 1 over 1 plus 4 over 5 plus 5 over 7. This is the same thing as what we have here, is the same thing as what we have here. So now for this, okay, now for this 2 plus 1 then over 1 over 1. So we have 2 over 1 then plus 1 over 1. So we are changing this into 3 over 1. So therefore we can say 3, therefore we may say 3 over 1 plus 4 over 5 plus 5 over 7. So we may then say 1 times 5 to get the lowest common factor. Now we multiply these denominators. We have 1 times 5 times 7 equals 35. So we have 35 here. So how do we arrive at these figures over here? So we then say 1 times 35, that's we then say 1 times 30. So we then say so we have 1 multiplied by 5 multiplied by 7 equals 35. So this is our 35 here. So we then say 1 multiplied by 35. No, this is our 30. To get our 35, which is here, we say 1 multiplied by 5 multiplied by 7. Then we have our 35. So we then say 1 divided. How do we get our 105? To get our 105, we may say 1 divided by 35 gives us 35. So 35 multiplied by 3 gives us 105. Let me bring forward my calculator. Let me explain how I arrived at that. Trying to resize, yeah, shape resize. So we have 35 multiplied by 3. Beg your pardon. By 3. So that's how we arrive at our 105. So how do we arrive at our 28? I hear somebody asked, how do we arrive at our 28? So we then see 35 divided by 7. No, divided by 5. I beg your pardon. Divided by 5 equals this 7. So we then multiply 7 by 4. This is the 4 we are multiplying 7 by. This is the 5 we used earlier. The 5 we used earlier. So we are using divided by 4. So we get our answer 28. And that's how we got this 28. So we got this 28. So we got the 28. So we are on 25. How do we arrive at 25? We can say 35 divided by 157 equals this, then we multiply by 5. This is the 5 we're multiplying it by, plus by 5, then we get our 25. And that's how we arrived at this and that at this. So when we add all this together, so we have our 158. So let's do this quickly. Plus 28 plus 105 equals 158. So we divide our 158. So this is our 158 here. About 158. So we divide it by 35. We have our answer as 4.5. This is how we arrived at our answer. So that's our final answer, 4.5. So we may therefore conclude that our answer equals 4.5. And that brings us to the end of this tutorial. I hope tutorial you make use of it, you make the best of it. Take your time, as I said earlier on, take your time to digest it, take your time to practice. And if you have questions you want to ask, you can always reach out to me. You can always drop your comment. I'll respond to every comment. Thank you very much. I want to say a big thank you for watching the tutorial, of for sticking around from the beginning of the tutorial to the ending. Um, I'll be dropping the next tutorial on Circle as soon as possible. I wish you all the best in your endeavors. Please let's not forget to, if you are yet to not so if you are yet to subscribe, use the subscribe button, click on the subscribe button and turn on your notification button and your notification bell. And please endeavor to share and like this video. Thank you very much, and I look forward to seeing you in the next tutorial.